Let f at n be negative 1 plus root 3I over 2 to the power of n plus negative 1 minus root 3I over 2 to the power of n. What is f? 2022. In this question, we are going to have to use de Moivre's theorem. And some of you are familiar with that. If you're not, no problem. I'll explain it. If you have a number or a coordinate that is of the form cos theta plus I sine theta, if you raise it all to the nth power like that, it will be the equivalent of r to the power of n times cos n theta plus I sine of n theta. So we are going to use this to figure this out, and in particular figure that out. Okay, so how do we do that? Well, the first thing is, of course, if you notice, these two terms are very similar. The first one is minus a half plus root 3 over 2I, and the second one is minus a half minus root 3 over 2I. So what I'll do is I'll do this one. You can do them together if you want, but I mean, I'll just do one at a time. Or I'll do one and then you guys do the other one. You do that one. Okay, so here we go. Using de Moivre's theorem. Now, we have to put it in this form, right? This form right here. So cos of something is equal to this negative a half, and the sine of something is equal to root 3 over 2, right? And we're trying to get this to look like this. So without too much problem, I can figure out that theta is 120 degrees, or 2 pi over 3 if you put it in radians, whatever. Okay, so that means that this guy basically is the equivalent of cos 2 pi over 3 plus sine 2 pi over 3 I. Got it? Okay, so what we want is we want this to be raised to the nth power, right? And what is our n in this case? Well, our n in this case is n in this case is 2022. Okay, so that means this is becoming 2 pi over 3 cos plus the sine of 2 pi over 3 sine I, all to the power of 2022. And that's where the magic of de Moivre's theorem comes into play. We have basically, there is no r, so we don't have to worry about that, but we just have to put this cos 2022 in front of the 2 pi over 3. And then we have the sine 2022, 2 pi over 3. And that's I. Let's put the I there. Okay. Well, that shouldn't be too hard to figure out. This is basically now, what is this actually? I think it's 1348, I think. Yeah, 1348 pi. And the other one is also 1348. Okay. So you said, well, how do I figure this out now? I'm not allowed to use a calculator on the American exams, but that's okay because the sine and cos graphs are cyclical, right? They repeat every 2 pi. So that's one wave period, and it just keeps repeating. So every 2 pi, it would be equivalent to 1. And this is divisible by 2 pi. So this means that this is basically 1. It doesn't take that much to figure that out, actually. You don't even need a calculator. For sine, it repeats like that, where every 2 pi, it's 0. So this is also divisible by 2 pi, so that's 0. So this is basically 1 plus 0, which is 1. Got it? So you do the exact same thing for the other one, which is this one up here. And I'll let you do that, and I'm certain that you can. And when you do that one, it also gives you actually 1 minus 0, which is 1. So what we had to do was figure out this plus that. This we just got was 1. This you will get 1, and therefore 1 plus 1 is 2. And that means that number 11, the answer is E. Kayla rolls 4 fair 6-sided dice. What is the probability that at least one of the numbers Kayla rolls is greater than 4, and at least 2 of the numbers she rolls are greater than 2? All right, so we've got a few scenarios here. We're going to actually figure out the complement first, and then subtract it from 1 to get the answer to this question. So the complement is the opposite of what they're saying. So the complement is as follows. First is that all 4 dice, die is the plural for dice, I think. Oh, whatever. And all 4 die are less than 4, right? And that we can figure out as follows. So if they're all less than 4, then that means that, well, each die has 1, 2, 3, 4, 5, 6 as the faces, right? So if all of them are less than or equal to 4, so that means they've got to be those 4 numbers. So there's 4 out of 6 chance that one die is less than 4. So for all 4 to be less than 4, it's 4 out of 6 to the power of 4. And we crunch out these numbers and put it in lowest terms at 16 over 81. So that's part 1. Part 2 is that you basically have met this criteria, at least one of the numbers is greater than 4, but you failed the next criteria. So at least 1 is greater than 4, but you have violated this one. At least 2 numbers she rolls are greater than 2. So that means if at least 2 of the numbers are not greater than 2, then that means you have, so we have 4 dice, right? 1, 2, 3, 4. We fulfill the first criteria that at least one of these is greater than 4. So let's say this guy was greater than 4. It was either a 5 or a 6. But then we have to fail this criteria, which says that at least 2 of the numbers are greater than 2. So if at least 2 of the numbers are not greater than 2, that means that we have only one of the numbers is greater than 2. So this is the only one. The other ones have to be less than 2. So this has to be either a 1 or a 2. This has to be a 1 over 2, or this has to be a 1 or a 2. So the probability of this scenario happening, well, we have this guy is 2 out of 6, and these guys are also 2 out of 6. So I guess that's it. Yeah. And then this can happen either here, here, or here. So we have, from those 4, we have to choose one of those die to choose the one that's greater than 4. So when you crunch out these numbers, this becomes 4 over 81. So the probability of P is basically the 16 over 81 plus this 4 over 81, which is 20 over 81, which is P. And then we wanted 1 minus P, which is the complement. So that's going to be 61 over 81. And 61 over 81 is D. The diagram below shows a rectangle with side lengths 4 and 8 and a square with side length 5. 3 vertices of the square lie on 3 different sides of the rectangle as shown. What is the area of the region inside both the square and the rectangle? So that region they have shaded. Okay, so we got to set this up a little bit. Let's see what I can do here. This is 4. That's 4. That side length. This is 5, so that's 5. This is 5, and this is 5. And since this is a right angle, that means that's a 3, 4, 5 triangle. So since we're told that's 5 and that's 4, this must be 3, and that's by far the most common Pythagorean relationship. So even if you didn't know that what this side was, you can just easily figure out using the Pythagorean theorem. So that's 3, that red line. So therefore, from here to here, let me think about this for a second. Let's see if I can put in some angles. If this is theta, and this is also 90, right? Yeah. So therefore, yeah, I think the angles are going to help us a lot here. So since this is 90, this one is going to be 90 minus theta. And therefore, this one is going to be theta, since they all have to add up to 180. And then therefore, this one in here is 90 minus theta. Yeah. So therefore, that means that we have similar triangles here. Okay, I got it. So therefore, this side here is going to be 4, and this side here is going to be 3. Yeah, this whole thing is 4, but that part is 3. Okay, I got it. Now, I just have to figure out this tiny guy here. That tiny one. Okay, the tiny one I'll draw over here. I'll blow it up a little bit. That's a right angle. And then again, this is 90. So therefore, this is theta, based on the fact that all angles add up to 180 degrees in a triangle. And also in a straight line, like if you have a straight line, all the angles from there to there are going to be 180. And therefore, this is 90 minus theta. So there you go again. That's another similar triangle situation. Okay, so this side I'll just call y, and this side I'll call x, like that. So y over x is the same as 3 over 4, because this triangle, this little guy, is similar to the other ones, all the other 3, 4, 5 triangles. So that means that 4y is equal to 3x, and therefore y is equal to 3x over 4, like that. And since this is 3 from here to here, this has got to be 1, since total is 4. And then therefore, this segment over here, this little guy here, would be 3 over 4, because y is equal to 3/4 x. Okay, so I think we have everything that we need. So the area of the shaded region would be the area of that big rectangle all the way around, which is basically 4 times 7. Yeah. And then we have to subtract those 3 triangles. So 1/2 base times height, 3 times 4, this guy. And then the next one, this one, 1/2 base times height, which would be 1/2 times 4 times 3. And then minus that tiny little triangle would be 1/2 times 1 times 3 over 4. And when you crunch out these numbers, you get 28 minus 6 minus 6 minus 3 over 8. And that is 15 and 5/8. And 15 and 5/8 is choice D. The graph of y is equal to x squared plus 2x minus 15 intersects the x-axis at points A and C and the y-axis at point B. What is tan of angle ABC? So let's draw a diagram, and let's see what we can figure this out. So this, I think this is a pretty straightforward graph. X squared plus 2x minus 15. I think it factors nicely. X, 3, 5, negative, positive. So that would mean 3 and minus 5 are the roots. So, and it's a parabola, so it's going to look something like this. Something like that, right? Where this kind of keeps on going forever. Okay, so what do we want here? We want intersects at A and C. So, okay, so this is A and this is C. And intersects the y-axis at B. Okay, so this is B. So we basically want this triangle right here. ABC, and then the tan of ABC. So the tan of this angle right here, we'll just call that theta. Okay. All right, so how do I do that? I think I'm going to have to use cosine law. Yeah. The cosine law would fit perfectly in this question. So first I have to figure out the lengths of BC and BA. Okay. Well, how do I do that? Well, this is 3 and this is 5. And then B I can get, that's the y coordinate. Y-intercept is what I meant to say. So that happens when x is 0. So when x is 0, that means that is minus 15. Okay, so this obviously was not drawn to scale, but that's okay. So BC, I can just use the Pythagorean, Pythagoras or the point distance between 2 points. I'll just use Pythagoras because that's quicker. 3 squared plus 15 squared square root. And that's going to be 3 root 26. And then BA, 5 squared plus 15 squared square root. And that's going to be 5 root 10. Okay. And then now I'll use the cosine law on this triangle. On triangle ABC. All right, so here we go. Cosine law, we're going to have AC squared is equal to BC squared plus BA squared minus 2BC BA or AB, whatever, and then cos theta. Yeah, and everything should fit. So we have AC. What's AC? Do I have AC? Oh, AC is just 8, right? From here to here. Well, that's easy. So that's 8 squared. BC squared is 234. Right, we have BC and BA. BA squared is 250. Yeah, 250. Minus 2 times 3 root 26 times 5 root 10 cos theta. All right, so numbers are not the greatest, but that's okay. 64 is equal to whatever this is, 234 plus 250. Oh boy, this is 30, and then root 260 cos theta. So put everything on one side, 30 root 260 cos theta, and that's going to be 420, I believe. So cos theta is equal to 420 over 30 root 260, and I think that is 14 over 2 root 65, so that's 7 over root 65. Okay, so that means if we have a triangle, and this is theta, the cos is 7, which is adjacent over hypotenuse. So using Pythagoras, you can figure out this side is going to be 4. And you can do that. Yeah, I'll let you do Pythagoras to figure out that side. So therefore, the tan of theta is opposite over adjacent. And opposite over adjacent would be just 4 over 7, right? Yeah. Is that it? I think so. Okay, so we're done. 4 over 7, and this question is E. One of the following numbers is not divisible by any prime number less than 10. Which is it? First thing I want to do is list the prime numbers less than 10. So those would be 2, 3, 5, and 7. So one of these is not divisible by 2 or 3 or 5 or 7. Okay. Oh boy. I think we're going to have to use mod here. So everything's a power of 2, I think. So we got 2 to the power of 1, 2 to the power of 2. What does it go up to here? It goes up to 600. Oh boy. So I got to figure out a pattern. So I think I can figure out a pattern pretty quickly. Because I think the powers of 2 repeat with regard to their units digit. So this is 2, 4, 8, 16, 32, 64, 128. 256, 512, and 1024, right? So what is the units digit here? Let's just write that down. Units digit. Units digit here is a 2, 4, 8, 6. 2, 4, 8, 6. 2, 4. Okay, yeah, just as I had imagined, it repeats. So that's helpful, because what that does is it allows us to figure out this in terms of a mod question. So those of you that are familiar with mod just means like the remainder. So for example, what would be mod 3? So when you divide this by mod 3, well, this will be -1. 4 divided by 3, the remainder is 1. 8 divided by 3, the remainder is 2. 6 divided by 3, the remainder is, hold on here, 16 divided by 3, actually, the remainder is 1. 32 divided by 3, the remainder is 2, and so on. So 1, 2, 1, 2, 1, 2, 1, 2, 1, like that. Yeah. And then I'm also going to try to figure it out in terms of mod 5. I think that will be helpful as well. Mod 5, this one doesn't help us. It's meaningless, but this one, -1, 3, 1, 2, 4, 3, 1, 2, 4. So there's a little bit of a pattern here. Okay. All right. So now let's go back to the question and let's see what we can figure out. So a little bit of preliminary work there to kind of figure some stuff out. Okay, so let's see what we can do. I think we're going to have to go through this choice by choice. I don't think that we have any choice here. So let's go with A. A is 2 to the power of 606 minus 1. Okay, well, 2 to the power of 606. Now, which mod do I want to use? Let's just see what happens with mod 3. Okay, so that's going to be 2 to the power of 606. So which one of these? 606, if you notice, every power of 4 gives the same result. Every multiple of 4 when the exponent is a multiple of 4. So is 606 a multiple of 4? And the answer is no. I think 608 is. So it's 2 before that. So it would be like these guys. It'll be like these guys. So that would mean it would be a 1. Yeah. So this would be mod 3. It would be 1. And then minus that 1, which is 0. Now, is that divisible by 3? Yes. 0. If mod 3 of this guy is 0, that means that this number is divisible by 3. So because it's divisible by 3, it is not one of the answers, because we want something that's not divisible by any of these primes. Got it? Okay, so let's keep going here. Let's go to choice B. So we got 2 to the power of 606 plus 1 this time. And this time I am going to use mod 5. I think mod 5 will help me here. Okay, if mod 5, then 2, 606, what is that mod 5? Well, 606 behaves like these guys. So mod 5, it'll be 4. Is that right? 4 or -1? Well, same thing, kind of. Let's just use -1. So we have that -1 plus 1, and that's 0. So that means that this mod 5 is 0. That means it's, when divisible by 5, it has a remainder of 0. So therefore, it is divisible by 5. See what I mean? So because it's divisible by because it is divisible by one of the primes, it's not a right answer. All right, so you just keep going like that. And let's just, I'm going to skip over C because C is the right answer. I'm going to show you D, and then I'm going to show you E. And then by process of elimination, you will be able to see that C is the right answer. But C you can do on your own. D is 2 to the power of 607 plus 1. Now 607 is going to behave like these guys. 607 is going to behave like this guy right here. This guy right here. 1 before a multiple of 4. So that, and then I've got to choose which mod. I think 3 will help me this time. Mod 3. That mod 3 will be a 2. So this would be like 2 plus 1, and that's 3. And that mod 3 is 0. So that means this is divisible by 3. So it's divisible by one of those primes, so that's not the right answer. And then E, that's the last one, 2 to the 607 plus 3 to the 607. Oh boy, I didn't anticipate a 3 here. Okay, we didn't do 3s, but that's okay. We can do it pretty quickly. 3 to the 607. Okay, so we got to figure out a 3's pattern here. Well, 2 to the 607, that behaves like 1 less than a multiple of 4. Which mod do I want to use here? I'll just use mod 5. So that's going to behave like these guys here. So mod 5, that's a 3, right? Yeah, that's a 3. So 2 to the 607 is a 3. Now I've got to figure out values of 3. Okay, oh boy. So 3 to the 1, 3 to the 2, 3 to the 3, 3 to the 4. I think 3 to the 5. So this is 3, 9, 27, 81, 243. So the units digit 3971. 3. Yeah, it's a 3971 repeating pattern. And then mod 5, this looks like negative 2. Let's see here. Mod 5 of those numbers looks like a negative 2, and then 4, and then 2 for the 27, and then 1. And then I guess it just drops down to 3, which is same as negative 2. So for 607, that's not a multiple of 4. It's 1 less, so it's going to be like this guy. So that's going to be a 2. So you have 3 plus 2, which is 5, which mod 5 is 0. So there you go. That's also divisible by 5. So all of these are divisible by something. This is divisible by 3. This is divisible by 5. This D is divisible by 3. This one I figured out was divisible by 5. So by process of elimination, C is the only one that would not be divisible. It has to be, but because everything else is divisible by something in this list of primes. Suppose x and y are positive real numbers such that x to the power of y is equal to 2 to the power of 64, and log x to the base 2 to the exponent log y to the base 2 is 2 to the power of 7. What is the greatest possible value of log y to the base 2? All right, so, oh boy. Okay, so first I'm going to make some substitutions. The first is I'm going to let x is equal to 2 to the power of a. All right. And I will let y equal 2 to the power of b. Okay. All right. So with that, now I will go back to my equations up here, make those substitutions. So that x to the power of y would basically be 2 to the power of a to the power of 2 to the power of b. And that is equal to 2 to the power of 64. And then in this guy, it's going to be log of 2 to the power of a to the base 2, all to the exponent. I'm going to need some more space here. Log of 2 to the power of b to the base 2, and that is equal to 2 to the power of 7. Yeah. Okay, so let's move forward. First, I'll move forward with this here. This can be combined a times 2 to the power of b, and that is 2 to the power of 64. So the bases are equal, so that means the exponents are equal. So that means that a times 2 to the power of b is equal to 64. And therefore a is equal to 64 over 2 to the power of b. And I think that's about as far as I can go there. Now let's concentrate on this one over here. Use some basic log rules first. You can put the a out front here, 2 to the power of 2 like that. And then the b, it comes out front, 2 to the power of 2 like that. And this is just 2 to the power of 7. Now this is just 1 and that's just 1. So this just becomes a to the power of b very quickly, 2 to the power of 7. So that's great. So now I'm going to substitute that into there. So we have 64 over 2 to the power of b all to the power of b is equal to 2 to the power of 7. So this is 64 to the power of b over 2 to the power of b squared, right? 64 is what? 2 to the power of 6, I believe. So this is really 2 to the power of 6b when you combine them. This is 2 to the power of b squared. And then let's keep on going. This, using exponent laws, is going to be 6b minus b squared is equal to 2 to the power of 7. And since the bases are equal, the exponents are equal. So that means that 6b minus b squared is equal to 7. And then if we put everything on one side, we get 0 is equal to b squared minus 6b plus 7. Now, unfortunately, this does not factor nicely. So we have to do a quadratic. So that's going to be 6 plus or minus the square root of 6 squared minus 4 times 7 all over 2. And this gives me 3 plus or minus root 2. 3 plus or minus root 2. And of those, the only one that's in the answer choices is this guy, C. Problem 17. How many 4x4 arrays whose entries are zeros and ones are there such that the row sums are 1, 2, 3, 4 in some order, and the column sums are also 1, 2, 3, 4 in some order? For example, this array satisfies the condition. Oh boy. All right, so we've got some array here. We've got 1, 2, 3, 4 rows, and we'll have 1, 2, 3, 4 columns. And each of them has these rules, right? So that, like for example, this one, this row adds up to 3, this adds up to 2, 4, and 1. This column adds up to 2, 4, 3, and 1. So it satisfies the rules. This is just an example that they've given you. So that means that we have to put 0, 0, 0, 1, or like 1, 1, and 3 zeros. And then we have to put 2 ones and 2 zeros, 3 ones and 1 0, and finally 4 ones. We have to put those in some order, in some column or rows. And, you know, that's how it kind of goes from there. Okay, so if you look at it from the perspective of the first row, we can put any of these. So I have 4 choices for that first row. And then for the second row, I've got 3 remaining choices from this group. And then I've got 2 remaining choices and 1 remaining choice. But then the columns also have to be kind of looked at, because if you realize one thing, that this has 2 rules, right? You have the row rule and the column rule. So the same story here. If you were kind of looking at it from a vertical perspective, it's the same kind of story. It's going to be like either that, or like this, or like that, or like this, and whatever variations exist. So for the first column, you also have 4 choices, and then you have 3 choices from this group, and then 2 choices, and then 1 choice. So in total, it's on the row area, it's 4 times 3 times 2 times 1 times 1. And then from the perspective of the columns, it's also 4 times 3 times 2 times 1. So then you have to just combine these. So it's 4 times 3 times 2 times 1 times 4 times 3 times 2 times 1. And that will give you the total, and that's 576. So that is D. each square in a 5x5 grid is either filled or empty and has up to 8 adjacent neighbor squares, with neighboring squares sharing either a side or corner. The grid is transformed with the following rules. Any filled square with 2 or 3 filled neighbors remains filled. Any empty square with exactly 3 filled neighbors becomes a filled square. All other squares remain empty or become empty. So here's an example transformation. And they're saying find what it should look like here so that when it's transformed, it looks like that. Okay, so let's talk about the rules. The rules are by far the most important part of this question. Okay, so any filled square with 2 or 3 filled neighbors remains filled. So this square is an example of that. It is a filled square, and it has 2 or 3 filled neighbors. In this case, it has 2 filled neighbors. Here's the first one, here's the second one. That one remains filled. So as you can see, when the transformation happened, it remained filled. Got it? Next rule, any empty square with exactly 3 filled neighbors becomes a filled square. Okay, is there anything like that? And the answer is yes, this one right here. It was initially an empty square, and it had 3 filled neighbors. Here's the first filled neighbor, second filled neighbor, and third filled neighbor, right? Because it shares a corner. Side or corner. And that one becomes filled. And that's exactly what they did. They filled it up. And is there anything else? All other squares remain empty or become empty. So everything else, so this guy, for example, it became empty because it didn't qualify in this criteria or this criteria. So as you can see, it's empty. This one also didn't qualify, so it became empty. And this one didn't qualify because it became empty. Oh, we got to talk about this one here. Why is this filled? Well, because when it was here, it fulfilled this criteria. An empty square with exactly 3 filled neighbors. Here's neighbor number 1, neighbor number 2, neighbor number 3. So these 3 rules are basically at the heart of this question. And then they're saying, based on those 3 rules, what kind of square can eventually be transformed into this? Okay, so I will show you which ones. So these are the ones that, when transformed, will end up looking like this. And we can go through the rules. Let's list those rules. Let's bring those rules in. All right, so let's talk about these rules. When this one right here, this guy, let's see, this one, this does not qualify in the first 2 rules. So because it doesn't qualify, it becomes empty. And therefore, it will be empty. And as you can see, it's empty up there. Now this one, however, it is in the first rule. It's a filled square, but it has 2 neighbors that are filled. So therefore, it will remain filled. And that's why it's remained filled over here. And then the last one, this one, and that one doesn't qualify, so that's why it becomes empty. So therefore, it will be transformed into that. Now there's 2 configurations because you can rotate this, right? And when you rotate it, if this goes over here, that becomes another configuration. So that's why you have 2 configurations. And very similarly, these guys, I encourage you to go through each of them. If you go through these rules, they will transform the shapes into that. Very straightforward. And for each of these have multiple configurations because you can rotate them. And that's pretty much all there is to this question. So you add up all these configurations, and when you do, you get 2 plus 4 plus 4 plus 4 plus 8, and that is 22. So therefore, the answer to this question is C. Number 19. in triangle ABC, medians AD and BE intersect at G, and AGE is equilateral. Then cos can be written as m times root p over n. What is m plus n plus p? All right, so let's draw a diagram first. Hopefully it will be somewhat realistic. Okay, so we got A, B, and C. Okay, so what do we have to do here? Medians, we got to draw the medians. So the median's AD, so this is obviously going to here. So this is D. So we have one median like that. Then we have median BE, so obviously that's going to be to here approximately. That's another median. And I don't need to draw another one, right? Do I need to draw another? But I'm going to draw it in anyway, like that, where I'm just going to call that M as the midpoint of AD. Now, why did I do that? Because when you draw medians like that, the point in the middle is called a centroid. And the centroid is very important because it has a ratio of 2 to 1. So, for example, I'll just call it C. AC to CD would be 2 to 1 in terms of their length. So a little bit more about that later, but that's definitely something that was going to help us. Okay, so I think we're going to have to use law of cosines here. So let me do some labeling first. Let me do some labeling. So AE I'll call A, EC I'll call A because it's the same because E is the midpoint. And then AGE is equilateral, right? What's G? AD and BE. AD and B. Oh, this is G. What I call C is G. Okay, so I'll just turn that into a G. Okay, I call it. So I guess this is G and this is G. All right, they've already kind of given me a letter. Okay, no problem. And they're saying that AGE is equilateral. So that means A to G is A and G to E is A. Okay, doesn't really look equilateral, but that's okay. All right, so that helps me. That helps me a lot because since this is 2 to 1, that means that this is A over 2. This GD, GD is A over 2. Okay, so that's very helpful. Okay. All right, so now I think I'm going to use law of cosines, but I need an angle. But since this is equilateral, this AGE, that means that this is 60 degrees. And so is that. And so is that. Okay, so I can use which triangle? ADC, right? Yeah, on ADC, I will use law of cosines. So I will use CD squared is equal to AD squared plus AC squared minus 2AD AC cos 60. Yeah, okay. So CD squared, AD squared is what? AD is 3 over 2. Yeah, 3 over 2A. AC is just 2A. So that's good. And then we have minus 3A over 2, 2A, and then cos 60. Okay, so crunch out these numbers. And when you do, you get 9A squared over 4 plus 4A squared. And this all comes to minus 3A squared. And this gives you 13, when you add it all up, 13A squared over 4. So that means that CD, if you take the square root, will be root 13A over 2. So this is root CD, right? Yeah, so root 13A over 2. Now, D is the midpoint of CB. So B to D is also root 13A over 2. Got it? Okay, so what do they want? Cos C. So this angle right here. So I'll call that theta. This cos C is what they want. So what we're going to need to do is apply the law of cosines again, but this time on ABC. Yeah. So that means AB squared is equal to AC squared plus BC squared minus 2 times AC BC cos theta, or cos C, whatever you want to use. You want to call it C or theta, whatever. And I'll let you do this. AC is going to be 2A. BC is what? 13, root 13A minus 2A, root 13A, cos theta. All right, I think we also needed to figure out AB, right? Yeah, in terms of A at least. Okay, well, AB, we can figure that out pretty quickly using a cosine law again, but I'm trying to figure out which triangle. This centroid from B to E would mean that B to G is 2A. Yeah. And then I think you would use the cosine law again on triangle ABE. Yeah, because we got the 60 degrees. This side is A, and this side would be 3A. Yeah. So I'll let you do that. It's pretty straightforward. And when you do, you get AB is equal to root 28A over 2. Yeah. So AB is root 28A over 2. So this is going to be 28A squared over 4. Yeah. Okay, so a lot of laws of cosines on this guy. Okay, so this is 28A squared over 4. This is 4A squared, 13A squared. What is this going to be? 4 root 13A squared, and then this cos theta. And I think all the A squareds cancel, so then we just get left with this 28 over 4 is equal to 17, right? 17? Yeah. Minus 4 root 13 cos theta. So this is going to be 4 root 13 cos theta. And then 28 over 4 is what? 7. So 17 minus 7, so 10. So this is just going to be 10 over 4 root 13 is cos theta. That's 5 over 2 root 13. Rationalize the denominator. And you get cos theta is equal to 5 root 13 over 26. 5 root 13 over 26. Okay, so we had to make it in this form, which it is, m root p over n. So m root p over n. So that means my m is 5, my p is 13, and my n is 26. And they wanted m plus n plus p. So that's going to be 5 plus 26 plus 13, and that is 44. 44 is the answer to this question, and that would be A. Problem 21. Let p at x be a polynomial with rational coefficients such that when p at x is divided by the polynomial x squared plus x plus 1, the remainder is x plus 2. And when p at x is divided by the polynomial x squared plus 1, the remainder is 2x plus 1. There is a unique polynomial of least degree with these two properties. What is the sum of the squares of the coefficients of that polynomial? So the first one, p at x, they're saying that when that is divided by x squared plus x plus 1, you get the remainder of x plus 2. Now, obviously, you're going to get some polynomial, and I will call that polynomial q at x. I'll call q1 at x because we're going to have another one. Then they're saying that when you take the same polynomial and divide it by x squared plus 1, then you get a remainder of 2x plus 1. And then, of course, we'll get some other polynomial, and I don't know what that is, so we'll just call it q2x. So we now have to basically figure this out, and off we go. So q at x, I don't know what it is, the first one, and I also don't know what q2 at x is. So my guess is that we are asked to find the least degree, So because it's least degree, I am going to make the assumption that it is of the form ax plus b, like that. And also q2 at x, ax plus c. But let's just work through with what we have here without getting too complicated. So let's go with the first one. Essentially what that means is that p at x is equal to q1 of x times that x squared plus x plus 1 plus the remainder. That's basically what that equation would be when you expand it. The second one, very similarly, would be p at x is equal to q2 at x times x squared plus 1. And now you're going to add 2x plus 1. So there you go. And I keep pointing out the least degree because that's very important, because that actually helps us a bit to know that they want the least degree, because we can just concentrate on what we feel is the least degree, which is just a polynomial where we have ax to the power of 1. And like I said, these substitutions are just something I made just to insert something for q at x and q2 at x. So I'll insert the first one. So that's going to be ax plus b, x squared plus x plus 1 plus x plus 2, right? And then the second one, I will insert ax plus c. And then we have x squared plus 1 plus 2x plus 1, like that. Okay, so far pretty good, but we have all these letters, and we also have a bunch of x's, right? So we want a system of equations, and the only way we're going to get a system of equations is by plugging in some values for x. So I will choose x equals 0, x equals 1, and x equals negative 1. When I put those values of x, I'll be able to get some sort of an equation, some sort of a system of equations. So here we go. Let's see what we get. P at 0 will give me, when I put x equals 0, it will give me b plus 2 for this guy. And for this guy, it will give me, I believe, let's see here, c plus 1. Yeah. Okay, p at 1, when I plug in x equals 1, for those two equations, I will get 3a plus 3b plus 3, and I will get 2a plus 2c plus 3. And p at negative 1, I will get a plus b plus 1, and that is the same as minus 2a plus 2c minus 1. So now we've got this system of equations here, and you guys can solve that. You've got 3 equations, you've got 3 variables, and that will be pretty straightforward to solve. So I'll let you solve that, and when you do, you get a equals 1, b equals 1, and c equals 2. So therefore, p at x is equal to, you can substitute it in either one of these, it doesn't really matter. I'll put it in this one here, x plus 1 times x squared plus x plus 1 plus x plus 2. And when you expand all that out, you get x to the power of 3 plus 2x squared plus 3x plus 3. Now what they wanted was the sum of the squares of the coefficients, right? Let's go back. The sum of the squares of the coefficients of that polynomial. Well, the coefficients are, this is 1, this is 2, this is 3, and this is 3. So the coefficients are 1, 2, 3, and 3. They want the sum of the squares. So we have to square them and then add them. And when you do, you get 1 plus 4 plus 9 plus 9, and that is equal to 23. So 23 is the answer, and that would mean that's choice E.